Hello everyone, this is my second video on index laws. In the previous video, we discussed what is a base and index, and we also discussed the first rule or the first law of index. So let's have a quick recap on what we did yesterday. For example, if I have a number written in the form of 3 to the power of 5, here 3 is known as the base and 5 is known as the power. Now 5 can be called as power, index or exponent. So if I want to calculate the value of 3 to the power of 5, this means that I need to multiply 3 by itself 5 times. So that is the expanded form, and if we need to find the value, we can just find it by 3 to the power of 5, which means multiplying 3 5 times, which gives us 243. So that was about base and index. We also discussed the first rule of index laws here. So in that we have, when the bases are the same and they are multiplied together, then the powers are added. So in this way we can simplify and write our answer in the form of a single index. I had also left 2 questions as homework unanswered. So let's begin by doing the 2 questions. We have here 4 to the power of 7 multiplied by 4 to the power of 9. Since my bases are the same and the bases are multiplied, the powers 7 and 9 can be added. So this can be 4 to the power of 7 plus 9. 7 plus 9 is 16. So this is the answer, 4 to the power of 16. Moving on to the second one, we had p to the power of 6 multiplied by p to the power of 8. So when the bases are the same and the bases are multiplied, powers are added. So 6 plus 8, we need to add the powers. So p to the power of 6 plus 8, which is equal to p to the power of 14. So that's the recap about yesterday's or last video. Moving on to the second law of index. When we have the same base, when the bases are divided, then the powers subtract. Let us look at one example of the second law of index. So if I have, for example, the base 3 to the power of 5 divided by 3 to the power of 2. Now since the bases are the same, both the bases are 3 and the bases are divided, powers can be subtracted. So this is 3 to the power of 5 minus 2, which is 3 to the power of 3. Now it depends. If we are asked to leave the answer in index form, we will leave it in the index form where we have the index as 3. Or if we are asked to write the value, then in that case, we can multiply 3 by itself 3 times. 3 3s are 9, 9 3s are 27, and we can write the answer as 27. But generally when we use this law, the second law, the first law, we are asked to leave it in single index form. Let's try one more question. If I have, for example, 7 to the power of 9 divided by 7 to the power of 6. So here again I have the same bases and the bases are divided. When bases are divided, powers are subtracted. So we have 7 to the power of 9 minus 6. 9 minus 6 is 3, so 7 to the power of 3. This is our answer in the form of a single index. So when we say single index, we just have a single index in the answer, whereas earlier we had one index here and one index here. So we simplify this and write our answer as a single index. Let's try one more example for the division law. So we have, say for example, 6 to the power of 7 divided by 6 to the power of 5. Again we have the same bases. Our bases are both same and the bases are divided. Therefore the powers will be subtracted. So the answer will be 6 to the power of 7 minus 5, which is 6 to the power of 2. So these are the examples for the second law or the second rule of index. Let's move on to the third rule of index. So if we have a base A to the power of m and the whole of it to the power of another number n, that means that we can multiply the two powers and write it as a single index in the form of a to the power of m into n. Let's do one example here. So this is related to the third law. So we have, for example, 3 to the power of 2 and the whole of it to the power of 4, say example. Now this is also known as the power rule. So we multiply the two powers here. So 2 and 4, we multiply the two powers. So we have here 3 to the power of 2 into 4, which is equal to 3 to the power of 8. Let us look at one more example. We have 5 to the power of 7 multiplied the whole power by 3. So here again we have 1 power of 7 and then the whole of this bracket is given a power 3. So here we have 5 to the power of 7 times 3. 7 3s are 21. So 5 to the power of 21. Let's try one more example of this category. If I have, for example, 2 to the power of negative 3 into 2. Now we don't have to fear the negative sign. We just have to follow the rule that we have learned. All we need to do here is we need to multiply the two powers. So minus 3 into 2 gives us minus 6. So we have 2 to the power of minus 3 times 2, which is 2 to the power of negative 6. So these are the first three rules. We discussed the first rule where we add up the indices when the bases are multiplied. That was rule number 1. Rule number 2 is when the bases are divided, powers are subtracted. So these three questions were with the second category. And rule number 3 was the power rule. So we have a to the power of m to the power of n, then the powers are multiplied. So these three were from the third category, rule number 3. Moving on, we will move on to rule number 4 now. Rule number 4 is we have a divided by b. So we have a divided by b and the whole of this is to a negative power. So now we can write this as a positive power. All we need to do is to swap the numerator and the denominator. So this becomes b by a and the power is now positive m. So let's look at examples to do the fourth rule of index. So for example, I have 2 divided by say 3 to the power of negative 4. Now if I want to write this as a positive power, then all I need to do is to take the reciprocal of the fraction. Reciprocal of the fraction means we have 2 by 3 now. All we need to do is to swap the numerator and the denominator, their positions. So we have 3 divided by 2, and since the fraction is swapped, the power becomes positive. And in case we are asked to work this out, we can also work this out by multiplying 3 4 times and multiplying 2 4 times. So the answer would be 3 3s are 9, 9 3s are 27, 27 3s are 81. So the numerator would be 81 and the denominator would be 2 2s are 4, 4 2s are 8, 8 2s are 16. So in case we are asked to just change the index and make it positive, we will leave the answer in this form. And in case we are asked to find the value, we will calculate the value. Let's look at another example. So for example, we have 5 divided by 2 to the power of -2. Now we want to write this as a positive power. What we can do is we can swap the position of the numerator and the denominator. We have 5 by 2, so when we swap the position or when we take the reciprocal, we have 2 by 5. So we have 2 by 5 and the power becomes positive. So if we need to calculate the value, we will multiply 2 by 2 and 5 by 5. So our answer is 4/25. Let's try one last example of this category. So we have, say for example, 2 divided by 4, you won't keep it 4, 2 divided by 7 to the power of -3. So we need to take the reciprocal of 2/7, which is 7/2. So we have 7/2 and the power becomes positive. So we have 7 into 7 into 7. If we need to find the value, 2 into 2 into 2. So 7 to the power of 3, that gives us 343 divided by 8. So that is about the fourth rule of index. Next one, we have the fifth law of index, and that is a very simple one. So all we need to do here is we need to understand that if I have been given any number and if it has a power 0, then its value is going to be 1. So let's try a few examples here. So we'll try it out here. For example, I have a number 6. So 6 to the power of 0 will give me 1. So it's just any number to the power of 0 basically gives me 1. So in place of 6, even if I have 6 million, to the power of 0 is 1. For example, I have 100 to the power of 0, that is also equal to 1. Or for example, if I have a variable, say for example, b to the power of 0, that also gives me 1. So basically, the rule is any number to the power of 0 is 1. Be it even a big number, say for example, 2500 to the power of 0, and that also gives me 1. So that was the fifth rule of index. Now there is no hard and fast rule about whether this is the third rule or this is the fourth rule. What is important is to understand the rules as the rules and to understand the examples and to be able to solve them. So these were the remaining rules of indices, and what you can do is you can rewrite these questions and try doing the answers on your own and then cross-check your answer from the video again. So that's all for this part of the video. Thank you very much.